Hello and welcome everyone to the latest episode of the Lowdown by Analysis.Tech. I'm one of your co-hosts today. My name is John Reimer. I'm a principal at Analysis.Tech, and I'm joined today by my colleague and friend, Dave Marcus. Dave, welcome. How are you doing today?
Hey, John, I'm doing great. Nice to be on as always, and looking forward to this particular topic. We've been trying to get James onto this podcast for some time, so I think it'll be quite a bit of fun. Let's just kind of kick off. I'll set the scene for everyone listening in. So, there's been a lot of noise lately about this idea of the fact that uh, all these AI investments that companies are making are only as good as both the knowledge and the context in which these AI applications actually work. If all I do is just give it bad data and bad information, it's really hard to expect that I can get anything reasonable out of it. And more importantly, something predictable. And we'll talk more to James about this as well. And so Rainbird, for which James is the CEO, is a company that has been doing quite a bit of work in the space. I met James and his team actually many years ago when I was at UiPath, and I would argue at that point in time it was possibly a little too early to kind of think really effectively about this. And then subsequently, we've met up again about 6 to 9 months ago or so, and had a deeper discussion. And I think this is a really good time. So, James, just to that kind of sets a bit of the scene here. We like to kind of begin this by asking our guests on the call about their journey, kind of how you got to where you are today. And can you tell us something that someone doesn't know anything about you, and not necessarily in a business context? So it could be the personal context as well, entirely up to you. Okay. And then yesterday, John and I were talking, and we were saying, man, it would be a great idea to also ask you why you called this company Rainbird. So let me start there.
Okay, so there's quite a lot. Well, listen, both of you, thanks very much for having me on. I'm glad we managed to get this in the schedule. My early career actually was as a software engineer. I mean, I started off working in big data on big mainframes, but I got very interested in how we could use technology to really help govern decisions. And so I spent nearly 20 years working in financial regulation and risk, really helping banks ensure that their staff were able to make good quality decisions so that they didn't, lose their banking license. So at one point, previous business that I co-founded ended up doing all of the anti-money laundering and sort of know your client training for all 30 of the world's largest banks. And so really, that got me interested in decision science and the human side of how we make decisions, particularly in high stakes environments. And then the last 20 years, have really been on how we can apply AI to decisioning. I had a very heartfelt belief, which was matched by my co-founder in Rainbird, Ben, which is that if we're to trust technology to make decisions, then that technology needs to, be accountable for what it does. But the challenge always was that didn't fit what I would say is the sort of saturated data mindset that all AI has to start with data. And so, clearly we all really love all forms of AI, machine learning, deep learning, and now obviously we have generative and now agentic models. But fundamentally, that's about making predictions based on some corpus of training data. And so my interest was always, well, what do we know as humans, which we might describe as knowledge, and how should we represent that knowledge in the tech stack and make sure that is, really a first-class citizen and can ensure that not just to enable us to make predictions, but how do we make judgments that we can really underwrite and have the explainability that comes with that. So I think it's something people don't know about me. Not many people will know this, but in a previous life, when I was in this big compliance world, we ended up working in information security and data security. So I did find myself at one point as a British, as an alien, contracted to work at the Pentagon, where my team and our job was to stop about 50,000 people from leaking secrets. And we also extended that to other parts of the US government, which was more than 25 years ago now, but a super interesting insight into the federal government. And then Rainbird. Yeah, Rainbird is it's an interesting story. I'll give you the very short version. But first, maybe just a caveat, right? Technical people are not very good at naming things. And so Rainbird started off as being Project Rainbird, and we never really had the time to think of another name. But it's actually a nod to Bertrand Russell. So Bertrand Russell, the philosopher and mathematician, who along with Alfred Whitehead wrote Principia Mathematica in the 20s. I mean, the first formal method of mathematics. That led to Alan Turing being able to build the Colossus machine, and really underpins everything that we have today in the world of AI. It's a rather obscure nod. There used to be a kids' TV program in the UK called Bagpuss, featuring this wooden woodpecker that was modeled on Bertrand Russell. And actually, Rainbird is an old word, old English word for a woodpecker, along with the apple, actually. So it's an obscure inside joke, but it's really a nod to Bertrand Russell, without whom none of this field would exist.
That is so cool. Dave, I think I'm so glad we start the podcast with that question, because
you should put that on your website if you don't already have it, James.
Yeah, we don't.
that is very, very cool. All right. James, I've been really just champing at the bit for this conversation, in part because the word context is thrown around so loosely in AI circles. And as someone who, reads a lot and researches this, it's like, what does this mean? How should I really think about it? Because it's so broad and it's used so loosely. I often, when we met and you described Rainbird to me, it sort of clicked to me. It's knowledge. I think that's what it is. But anyway, please break this down for us. Are there different types of context we need to understand? Is it really knowledge? Is that what it really is? What we're really going for?
Yeah. Okay. So I'll give you my view. Like a lot of terms, it's become horribly overloaded as a term. And actually, so, there are some people who say there are 4 types of context or whatever. I think we can really keep this simple. There are really two types of context that really matter. There's sort of a third. So maybe I'll just dismiss the third first, because I don't think it's really context. People talk about the context window. So when we sort of try and give LLMs information, when we instruct them, right? And I'm going to use that term. We might say, ask them a question and give them a load of context, and we kind of maybe give them some PDFs. LLMs have a context window size, which people just need to think of as a buffer, okay? But I don't really think that's context. I think that conflates it. So I'm going to sort of let's call that a buffer. It's kind of what the LLM can handle as a window, and dismiss that, because I don't think that's really context. So the 2 types of context that really matter, I'm going to call a policy context, and I'm going to say case context. Now, the case context is the fact of a particular question that we want to ask, or some kind of transaction with the model, right? So we want to ultimately, people are trying to make decisions. So if I say, well, I've got this customer and, this is my information about him, and I have a question that I want to ask, that is case context, right? So you need that once. But once you've finished that interaction, it's largely irrelevant to the next case, right? So that's the sort of transaction level context. And really, we can just think of that as, it's really just data, right? But it's all data, but it's kind of the transaction level. Now, policy is what I think is knowledge, right? So policy context is everything that we want the model to take into account when we want to judge the case. Okay. So this is what we want to encode, or provide to some kind of AI model. And I think we could say that that's general, right? It's something that we want to be used across multiple cases. So if I wanted to build an AI agent that was able to decide whether banking transactions need investigating for money laundering or fraud, okay, there's a whole corpus of regulation and policy, procedures, there's tacit knowledge that sits in people's heads. And I might just group that together and say that's kind of the policy context. That's how we want the case to be judged. The case context is the transactions. And I think the industry mixes this up, because with a large language model, everything ends up just kind of being injected into the model as tokens, right? So you might go, here's some transaction data. here's the policy as a PDF file. Please don't hallucinate. But all of that is just kind of input tokens. It kind of gets all mashed in together. And of course, the nature of the way LLMs work is input tokens influence output tokens. I mean, that's really how flat it all ends up being. But it's in flattening that where auditability dies, and because it just all becomes convoluted. And actually, what you want to be able to do is to say very clearly, well, this is case context, and this is the policy over which we want that to be judged. So, is context knowledge? I mean, it is for me. The case never is. It's policy as a general term, and you really need to treat that knowledge as something I think that can be executed on rather than simply read. Right. And maybe we'll get to expand on that a little bit. But in Rainbird's world, policy is a graph. It's a structure that we have an engine that can run against in the face of case facts. In the case of case data, right. Which is why we want to be able to very clearly say, look, this part of our reasoning came from context in the face of this data. It's much more something that we can relate to as humans in the way that we do human work.
That's really, really helpful, James. Thank you. Dave.
So, James, just to add to the points you've just been making, it kind of feels sometimes that this whole knowledge capture and store is something that's always been fairly hard to do. I remember years ago, when I was at Microsoft, we were getting very involved in this whole concept of like knowledge management. It was a very big topic, especially in the early days of tools like Microsoft SharePoint. And, we spent a lot of time figuring out how to interview people, how to have the right documents, how to have the right metadata associated with that information so that somehow we had kind of a corpus of knowledge that these tools could work with. Is this still a laborious thing to do? And if not, then how has this advanced and changed over the last, number of years?
Yeah, it's a really, really good question. So maybe let's start by just thinking again about knowledge, because knowledge sort of takes various forms. And you're right, there's been eras of knowledge management coming into fashion, and SharePoint's a good example of that, right? But I think it's really struggled. I think businesses have historically struggled to get value for their investment in knowledge management. And of course, knowledge is now becoming important again because people realize this is context for AI agents, right? So getting our knowledge in order. I mean, we've had 25, 30 years of trying to get our data in order. Now we need to get our knowledge in order. And part of the challenge is that when you create PDF files or policy, or if you put it in SharePoint or any kind of structure, that knowledge is not inherently computable. It can be written to be ambiguous. Different people will interpret it in different ways. But now we're trying to think about, well, how can we build a knowledge layer and then make that knowledge layer computable? But to tackle the question first about how do you do this and the historic challenges, knowledge capture has always been really hard. You're right. And it was incredibly difficult. But let's just acknowledge that some knowledge is explicit. It's kind of already written down. I mean, regulation is the most obvious kind of explanation of that. But you have these layers. So you maybe have regulation at the top, and then maybe you have policy. Like a bank would create policy sufficient to cover the regulatory obligations, but banks may have different policies. And then policies beneath that, you may have procedures that people write down, and the procedures are designed to adhere to the policy. And then maybe below that, you have controls where people are going, well, can we be sure the procedure is being followed? And you end up with this whole stack of kind of knowledge that's not really architected in a way that makes that particularly easy. But beyond that, you have an awful lot of knowledge that lives in people's heads. And Rainbow, we just call this tacit knowledge, lots of words for it, tribal knowledge, gray knowledge, etc. Let's call it tacit knowledge. So we have explicit knowledge in layers that's written down, and we have tacit knowledge in people's heads. So, and actually, it's the tacit knowledge that differentiates one organization from another. Right. So if you think about the big four, they would say, well, their institutional knowledge that's embedded, some of it's written down, some of it's tacit in people's heads, are the crown jewels. And actually, if you think in the world of generic frontier models, it's probably the only thing that separates one organization from another. So getting that out of people's heads and standardizing it into, let's say, an ontology that becomes computable for the AI age, has tremendous rewards, but it has always required a process that is called knowledge elicitation, right? And it's a whole field of science to do this. And we've spent over a decade building tools to elicit knowledge from people. And actually, one of the reasons why we don't have more of this kind of logical symbolic AI is because knowledge has always been very hard to capture. And frankly, this has been 20 years of my career, at least, sort of thinking about this. So how is this? So this is easier today. It's easier today because we have, for the first time in history, the tools that we need to be able to extract knowledge through a process of consultation and, as you say, interviews. And this is built on some behavioral science. So and there's also informal ways that people have captured this tacit knowledge, but not so much in PDFs and structure. So it could exist in Excel spreadsheets. It could be some Visio diagrams. It could be old code. It could simply be, particularly in these days where people have lots of virtual meetings, transcripts of conversations with experts. It could be an email. It could be in Slack. So there are digital tools that can extract this knowledge. There's tools that can interview people. I mean, LLMs are fantastic at doing this. And so we can leverage these large language models, which at the most advanced end are perfectly capable of actually synthesizing this kind of knowledge material. And then going, well, do you agree or disagree with this? I mean, so we know that there's a danger with large language models that they can hallucinate and come up with things that are a mistake. But one of the really powerful things they can do is just draft things. And working from a draft is so much easier than starting with a blank page. So with all these techniques together, we're able to create, in Rainbird, we can literally take a use case problem statement. We can leverage the very latest LLMs, and we're pretty agnostic as to what they are actually, to build obviously you can go research all regulation and policy and all the public policy and regulations that's written down, but then synthesize the expert data and present that to experts to say, well, poke holes in this. And it's so much easier to say, well, I would look at this a bit differently. Will you just tell it that how you look at it differently, and it can pivot the model. So yeah, that's a really some really powerful tools now, but this would not have been possible pre-LLM. So the irony is, LLMs have created all of this tooling for us to be able to get knowledge into a better order. And even though I don't trust LLMs as reasoners, because they're not reasoning, they're making predictions based on a distribution of probability based largely on public training data. They're very good at manipulating content into a structure that maybe is computable. So I'd say, look, in wrap up, for most cases, it's possible to build extremely sophisticated ontologies grounded in regulation policy and then enriched with human knowledge to a density that enables it to have everything it needs to make decisions, and to do that now in hours rather than months. So actually everything has changed, and we have LLMs to thank for that.
Fascinating. You've uttered the word ontology twice, James, which most people never say that word once in their entire life. So well done. Hey, folks, thanks for tuning in to the Lowdown by Analysis.tech. This is a mostly weekly podcast devoted to all things, what do we say, Dave? Low code, abstracted development, AI in the mix. We're Analysis.tech is an advisory and research firm. And we study these topics. We look for advice for both vendors and customers, and how to do well in this world. If you like the content, tell your friends, tell your neighbors, hit the share button, hit the like button. We're here to serve the community, and thank you for tuning in.
Yeah, so maybe just to add to that, John. For those of you who are interested in more information, we have over 100 of these podcasts published right now. And in addition to that, we have a bunch of research published on our website. Unlike a bunch of other analyst firms, we don't gate our research from a cost point of view, other than asking you for a business address or email address. And so go and take a look, let us know what you think, and give us some feedback.
Thank you, Dave. So James, let's drill into, you mentioned knowledge can be put into a graph, which is the way you guys operate, way you guys manage it. Let's drill into that a little bit more. Again, context being a very broad topic, and people being sort of sloppy about really defining it. I think there are also many ways that people talk about encoding context for AI. They talk about RAG. They talk about there's people using vector databases in various ways. Let's talk about the techniques here and why a graph is a good way to go and how it compares maybe to some of the other options that people are using.
Yeah. Okay. So let me try and break this down and make it easily digestible for your audience. So,
Thank you.
knowledge graphs have been around for 20 years, right? And most knowledge graphs are a database. They just happen to be a database where we're able to express any number of relationships between data. And so therefore it's kind of like a bit of a network structure, and it's good for particular types of data and for doing analytics over that. Now, we happen to be using a knowledge graph to represent knowledge. We sort of separate the data and we build an ontology. A graph is really an ontology, and we can enrich that with, I'm going to call them rules, but they effectively are individual nuggets of wisdom that sit on this map of knowledge to form a domain model. So when we want this all to be computable, we want to be able to compute over knowledge, I'm going to use that term, with absolute precision, no risk of hallucination, deterministically, and have an audit trail. Because when we're in the logical world of graphs, we're capable of creating a causal chain of reasoning, rather than taking knowledge and then just giving it to something else to do the work. Now, most AI architectures still rely on taking material and handing it to an LLM today. So the LLM can, I'm going to choose my words carefully, can form an impression. Okay. And often that material is pulled from a vector database using RAG, retrieval augmented generation, which for those who are unfamiliar, it was measuring the sort of the thing about the angles between vectors. It actually uses cosine similarity. It's the basis of all semantic search. It's been around for a long time. It's not new, this idea of vector databases. But to kind of find the bits of text in a big corpus that's been turned into this vector database that kind of look mathematically like they might relate to the question. It's all very hand-wavy. It's like, is there anything in this corpus that looks like this question at a mathematical cosine sort of similarity level? And if it is, let's grab those bits of text and give it to the LLM, because we can't give the LLM everything, because with that context window, the buffer we talked about, was a little bit limited. So retrieval matters because large language models have that limited context window and you just can't ingest everything, but it's a compromise. So I'd say it's very good for searching and summarization, although it does struggle with very large corpuses because the difference in the vectors between things becomes harder to detect. So if you want to say, what's the policy for X in jurisdiction Y, that's search, right? You're searching and summarizing, really good at that, but there's no reasoning there. Right? That's just search and summarization. So we're searching and summarizing for bank of material. Part of the challenge is that when you prompt a language model, you're giving it material as input tokens, as I said earlier, which influences output tokens according to a probability distribution learned from training data, which means that's going to be influenced by what some kid said on Substack, right? Because that's in the training data, and it's non-deterministic. So you may not get the same answer twice. And this is the smaller side, but I'd always make this point. It's one of the reasons I've always struggled with the term prompt engineering, right? Engineering disciplines don't normally produce different outputs for the same inputs. Doesn't sound like engineering. And so we call it prompt wrangling at Rainbird, because people need to not fall into the trap of thinking these models are deterministic. So by contrast, a Rainbird graph is a sort of world model. So it's a formal structure of knowledge on an ontology, a bit like a map, forming a reusable, I'll call it a knowledge map, a knowledge graph, right? And you can actually join these together to sort of create this federated, unified knowledge layer. And now it's possible to do that at an enterprise level, right? So, and then we reason over that layer using a symbolic inference engine. Now, what on earth is a symbolic inference engine? It's a big pile of calculus. It's a mathematical logical engine that chains through this knowledge. It actually goes backwards from the goal. and combines all this logic in the graph, which is the kind of policy context, with case data, which is the question we've asked, to reach a decision that is entirely grounded in that knowledge, entirely deterministic, and comes with an audit trail, which is why we'll say it's a causal chain of reasoning. So when I say Rainbird computes over knowledge, I mean, it's literally a calculus engine navigating knowledge in the face of data, making determinations with the same certainty that Excel would if it was adding up numbers. So knowledge is a first-class citizen and can be reasoned over without the language model being allowed near the reasoning. We can use it to structure data. We can use it to be the user interface. But the actual core of this architecture is computable, and so that's something that retrieval, RAG, and prompting and fine tuning and other ways of trying to shove context into an LLM to influence those output tokens is that's why I say it's hand wavy, right?
Right.
So maybe there's one other very quick point to make. The other important point is that retrieval can only surface what somebody else has written down. Realistically, you're searching and summarizing something that exists. This graph method, because it contains rules and it has an inference engine, there are rules in there that have never been combined by any other process and therefore can reach conclusions that are not documented. It's actually generating new knowledge. That is what inference is. And that's what Rainbird is. It precisely, repeatedly, transparently take everything we know and generate new knowledge, right? So most of the difficult decisions people want AI to make sit at the intersection of kind of rules from different sources. And nobody necessarily has authored those intersections. So the model, if you have the model and you can write inferences over it, that's the problem that you can then go solve.
That's really helpful, James. Thank you. Dave?
So, James, let's dive in sort of a little deeper, especially in the context of Rainbow itself. So, context and knowledge feel like they require some kind of a defined architecture at both the business and the technology level. It'd be useful to try to understand the context of Rainbow, sort of what that architecture looks like. The other thing is, do people have to think about this as, is it built specifically for each organization, or is there a way to be able to get sort of a shared infrastructure or architecture or tool set that helps to do this? And then, in the same way as you talked about the word context is, becoming confusing because it's been used in so many times, even the sort of context graph and knowledge graph technology, Microsoft announced something and ServiceNow announced a knowledge graph. And so how do you see those as different from what you guys are doing?
Yeah, so it's a good question, and again, we can talk about context being an overloaded term. Knowledge graphs are a horribly overloaded term. Most knowledge graphs are a database. Context graphs are the ability to kind of try and graph a process that some agentic piece has gone through. It's a little bit like trying to gather the exhaust fumes of what happened and try to retrospectively put an ad hoc explanation together of maybe what a process was. But the reality is, if you think about a large language model as a bit of an opaque black box that's kind of got all of its weights and in there, breaking, before we had this idea of what's called chain of thought and chaining LLMs together, or having an LLM, as the modern ones do, build a process for themselves, right? And then say, I'm not going to rush to answer the question. I'm going to devise sub-agents and I'm going to try and break this down. That's great. And we love that, right? Because it reduces the chance of error, but you can't get to precision by taking something that's, non-deterministic and unauditable, and then, breaking that into lots of versions of that and having them all talk to each other. That it doesn't make sense. Sort of common sense that you can't kind of do that. So, so there are lots of different terms that are out there. I think, this needs an architecture to work properly. So maybe if I just cover that, it might break it down a bit. So we talked about case context, or we just call that facts. This is just data that comes from a system of record and is transient. Okay. Knowledge, which we've said is the policy, is held in this executable model. And because of that, it can be versioned and owned by a business. It's not something that, sovereign. It belongs to a company. We have customers that are modeling their knowledge in Rainbird. They won't let that go outside their firewall, right? So they put Rainbird on premise and they build this knowledge layer, and that knowledge is now there for the next for decades for agents to come and defer to. We've got inference, so the process of reasoning over that knowledge, and we don't let LLMs do that because they make mistakes. So we do that using a logic engine. And then when we run that through, we have evidence. Okay, so these are kind of all the layers that are there. And you know, Rainbird is not an alternative. It's not really trying to displace anything. It's trying to say language models are exceptionally important, right? But they kind of sit at the edges. There's lots of things that agents can do, right? Gather data, dealing with messy input and output, natural language processing. But LLM as judge is a bad idea, right? So they should stay out of the middle. And if you sort of take all this knowledge and kind of reasoning, and of course it doesn't help because the frontier models, you know, people sort of pop up and say, well, you know, it's reasoning or it's thinking. These are all, again, terms that have dictionary definitions. Reasoning is a logical process. There's nothing logical going on with an LLM. But if we sort of say, let's just take the knowledge layer out separately, we build that as a fabric, as a kind of a symbolic layer. We've got reasoning, so reasoning away from the LLM. We build that out as a layer alongside the knowledge, right? Now we have this really healthy abstraction where everything is much more straightforward. We have a knowledge layer that, you know, thanks to no-code tools, and, you know, you can build Rainbird knowledge graphs we've got a Claude code skill. You just give Claude something like Claude, and other LLMs apply, right? So you can give it to Gemini and other things. And it knows how to build Rainbird models. It even puts them in the Rainbird studio. But you have this whole ecosystem for managing knowledge, which really belongs in the business, not an IT function at all, right? And the ability then to have a wrapper around that, so that so you've data below, and you've kind of got orchestration and interface above, and then you've got these nice layers. So, but this people, you don't need to custom build this architecture on a project by project basis. And I think one of the things that's really interesting is, and amongst our customers, is lots of people have almost in like a kind of a citizen developer way, have kind of gone and run around and built lots of different things. And there's no real solid thinking about architecture, except that has now changed, where, you know, an organization the size of a bank, for example, is going, let's settle on an architecture that enables us to be sure that we have a trust component that is rooted in policy, that sits between LLMs, which everybody loves playing with, and systems of record. Right. So the promise of agentic AI isn't all these multiple agents. It's the fact that those models can have agency to go and take action. But there's some very public examples where systems of record have been destroyed by LLMs. I mean, one organization had its entire IP deleted, including the backups, because an LLM went rogue, and there's lots of examples of that. So the Rainbird is sort of neither build nor buy. It's a platform that enables people to be able to stand this up in different domains. Nobody would go and build a database engine today, right? You just go and, if you want a graph database, you'd use Neo4j, or you use Microsoft Stack, or somebody, you'd use SQL Server, right? Rainbird is just if you want to build a spreadsheet, you're not going to go and build an Excel, are you? It's infrastructure that's there for you to build your spreadsheet. So Rainbird is the layer that enables you to build out that knowledge, and at our humblest, and make that a sub-agent or a tool call that anything else in the world can call on when you need a decision over policy that is deterministic and auditable. So people assume it has to be a custom build, because historically the building of these systems was extremely challenging, right? It required you to build inference engines would have not even just required normal software engineers. You'd need to be knowledge engineers that are experts in philosophy and linguistics and math and probabilistic sort of maths, which is very sort of slippery. So those constraints have all gone. We use LLMs for building these. We use LLMs for talking to them, but we keep them out of reasoning, and we just keep this architecture separate. And then everybody can have what they want. They can have all of the benefits of LLMs, but they get to go through the trust and risk people and get these use solutions to production, which matters because at the moment, 95% of these projects never see it to go live, largely because of these issues.
Interesting. You mentioned one of our questions was, what can go wrong if you don't have this kind of an architecture? You mentioned there was one episode where an LLM went rogue and wiped out a whole system of record. is LLMs going rogue? Is that the risk that an architecture like this will mitigate, or are there other downsides if you just rely too heavily on LLMs?
So I think there needs to be a recognition that the future of AI is hybrid. It's not any one technology to deliver a solution. And I think as a society, we tend to pendulum swings from one cool thing to the next cool thing, right? So we can even go back to the 80s and 90s when there was no machine learning, and beginning of the 90s, sort of late 80s and early 90s, it was all about symbolic AI, which was all about knowledge, was all in fashion. It was about expert systems and knowledge representation and rules, and people putting billions into that. It was a big blisteringly hot summer of AI. And then the pendulum swung towards machine learning, and everybody's like, well, we'll kind of forget this knowledge stuff, and then it's all about data. And then this era of symbolic AI, of sort of rules-based AI, kind of just retreated back to academia, sort of scurried away. The future is about combining things together. AI was never one thing. It was always a broad church of technologies that need to come together. But to answer the question, I think there are 4 bad things that can happen. Okay. The first is the non-deterministic nature of LLMs needs to be respected. The same case gets a different answer on a Tuesday than it did on a Monday, and nobody can quite tell you why, right? Regulators simply will not allow you to treat 2 customers differently. It doesn't matter whether it's healthcare or it's financial advice or what it is, right? So you need something that's going to bring determinism. And traditionally, that means writing software or code or rules, but they're very limited and brittle. You can only write a decision tree that does something really simple. This neurosymbolic approach, which is what we've really pioneered, and there are others that are now trying to jump on this, is this idea of being able to combine both. I want all the properties of being able to deal with uncertainties like LLMs, but I want the determinism of rules, but in a bigger construct where I can do complicated things, right? The second thing is untestability. So if you go back to your RAG point, right? So when policy lives as vectors or prompts rather than in a graph, of course, even in a graph, you're going to give a graph to an LLM, you have the same issue, right? There's nothing really to test against. You can't check it before deployment because there is no it. You can't see inside that box as to how it's handling what you're giving it, and it's non-detectable. So it's not only is it not testable, it's not inconsistent. So and people need to just respect that limitation. It's super powerful, and it belongs in the stack, but you don't want to be in a situation where you can't test something, and then 2 years down the line, you're in trouble with a regulator, or you've got a fine, or you've got complaints from customers. And there's loads of examples of this. Mm-hmm. The third thing is drift, right? So policy changes over time, and systems don't, because there's no place to say, oh, this rule has changed in this policy. I want to go change that rule, right? If all you're doing is prompting an LLM. And so we end up with situations where we've seen this a lot, where LLM-based agents, even if you build really sophisticated multi-agent systems, really struggle with the fact that different policies may have applied at a different point in time. So you have policy drift all the time, and then it's a temporal reasoning. How do I judge this case by policy that maybe in the mind of an LLM has been updated and everything? That's a real issue. So drift generally is an issue, but that's one example of drift. But the single biggest weakness is a lack of explainability. And we have these 2 terms I try and sort of disambiguate. Explainability has become a word that's about understanding how the model works. Auditability is about understanding how it made a decision in a particular transaction. And language models, unfortunately, can produce extremely plausible explanations as to how they're working, and extremely plausible explanations as to what they did in a particular transaction, but those are not necessarily true because you cannot describe a process accurately when no such process exists. But it's so convincing that people, I think, even people that invest in this technology, that are deploying this technology, they fall foul of not recognizing its boundaries. And these are innate limitations. Its inability to be able to provide an audit trail for how it's reasoned cannot be fixed. Doesn't matter how great the next model is. So are you going to allow the next LLM to go run, all the share award decisions for an organization that's hundreds of thousands of staff, when it needs to be the decisions based on regulations in 200 countries. And maybe you have to sell some of those shares to pay a tax bill in one country, and none of that can be rolled back. Why would you ever use an LLM for that? You need a deterministic set of computable policy to be able to make those sorts of decisions. So they're the big challenges as I see them, broke them down, and it manifests in some of those big outcomes like people losing things.
So, James, in the enterprises that you're working with, which typical roles is this message both landing best with? And then are there people who are or should be responsible for implementing these types of knowledge architectures? And if so, who are they? And in fact, are IT geared to doing this, or is this more of a business function?
No, that's a good question. And it has a sort of a multifaceted answer, I think. So different parts of the business care differently about different things, right? So business people, so we work with global heads of tax, for example, for big accounting firms. And then it's very easy for them to say, I'm not putting anything live unless it's deterministic, unless it can make the same decision every time. It's just not going to happen. And then you might have some IT people that are working with agents that don't care as much because they're not invested in the regulatory kind of implications of this, and work gets done, like spend a year trying to build something that the risk team won't put live. So I think there's really mainly three roles. I think you've got a policy owner. So somebody owns this knowledge layer. And that typically sits in the business. Right now it sits in documents. But I think if you think about this idea of a knowledge architect who can build this layer and keep that layer as separate from everything else. Because however much an LLM, whichever LLM you use, whatever the next frontier model is, you need your knowledge to be in order. You want it to be something that can be, that context to be available. So somebody needs to be architect that. And actually there's a role that goes back to the 80s and 90s called a knowledge engineer, which is a role that very few people have on their org chart today, which is the person whose responsibility it is to manage that knowledge layer. And the trouble is the obvious IT candidates for this job are the wrong ones, because I mean, data architects kind of, they're trying to govern data and what's true from data, but not that doesn't really follow into this knowledge space. Data scientists, I would say, there's two types of data scientists. There are those that kind of get the role of knowledge, and those that I think have just been so immersed in the data mindset for so long, they find it very difficult because they're trained to derive rules from data. Whereas here, the rules are a given. They're enshrined in regulation and policy in people's heads. And the job is to represent that rule set faithfully in a way that is inherently computable. And I should say, by the way, that when you build this knowledge layer, one of the benefits is that's you now have an unambiguous standardized set of policies. Before that, you probably had people that disagree over that. Mm-hmm. So surfacing gaps and conflicts and where policy disagrees, and being able to make recommendations for normalizing and resolving that gives you a much better set of policies that not only can agents use, but now there's no ambiguity over them. There's no uncertainty. Banks spend hundreds of millions of dollars trying to get that right. Okay. So the right fit actually is a business analyst for me, because they've been eliciting business understanding from domain experts for 30 years, but without that title. And that now works because the knowledge engineering bottleneck is gone, because we can use a language model, as I said, something like a Claude skill, right? If you're a business analyst and you're able to create problem statements and really being able to think about what it is you're trying to build, you're leveraging this amazing black box model that's good at manipulating language to go build a glass box model that is visible, open to introspection, testable, and is yours. And then the analyst can verify and sign that off. Okay. And so I think business analysts analysis is this key set of skills for being able to manage this knowledge layer. But it's owned by the business. It's not owned by IT, in my view.
Right.
Yeah, it's interesting that you mentioned that. I saw a note on LinkedIn from a friend of mine, Francois Agenstat, who has a new analytics company, and he made a really interesting point about the new role of the business analyst yesterday, which was quite fascinating.
Yeah, I agree entirely.
James, thank you so much for sharing. and so clearly expressing the ideas and the concepts and the distinctions that you've walked us through. This is going to help a lot of people. I know I've learned a lot. I had high expectations for this conversation. You have exceeded them, my friend. This has been fantastic. Thank you so much. People want to learn more about Rainbird. It would be, if you just type in Rainbird, you find out all about sprinkler parts. So how do they get to you, James? And the
Rainbird AI. Yeah.
Rainbird.ai. Okay, there you go.
Rainbird.ai, or just type Rainbird and the word AI. You'll find us. Please, connect on LinkedIn. We just love having this conversation. It's been a real pleasure, both of you, John, Dave, and thanks for giving us the chance to talk about this really interesting space.
Thank you.
Thanks, James. Chat to you again soon.
Take care.